So we're going to talk about factoring by grouping. But before we talk about factoring by grouping, let's go through our checklist and remind ourselves where factoring by grouping ends up. So what is the first thing that I look for when I am factoring?
Greatest common binomial.
I look for a greatest common binomial. What's the second thing that I look for, Phoebe? A difference of squares. What's the third thing that I look for, even though I know most of you just go straight to finding binomial pair of factors? Trevor? Look for a square binomial. The fourth thing that you do, binomial pair of factors. Now, the binomial pair of factors, just to remind you, binomial pair of factors, if you have something that is written in the form x squared plus bx plus c, that's when you're going to do your factor sum table, or you could do the rectangles. If you have ax squared plus bx plus c, noticing the difference here is there is no number in front of here that's written, and there is a number in front of here. This is when you're going to have to do your possible factors and linear term table. And then finally, the last form of factoring that we are going to discuss is factor by grouping. That was a 5. It now looks like an 8. OK. So we're going to deal with very basic factor by grouping today. So looking at question A. Looking at question A, we have A times the quantity x minus 3 plus C times the quantity x minus C. What do you notice is similar about those two terms? What do you notice is extremely similar about these two terms? X minus 3. They're both being multiplied by x minus 3. So in other words, if you were to expand this, you'd have a times x, a times negative 3, c times x, c times negative 3, right?
Yes.
So what we're doing is we're multiplying a times this binomial. We're multiplying c by the same binomial. Well, wouldn't it just be easier if we combined these two terms, a plus c, and multiply them by x minus 3? Yeah, it would be a much simpler way of writing. And just to prove that it works out, you have a times x. That happens here. You have a times negative 3, which happens here. C times x, which happens here. C times negative 3. Oh, look at that. We just did the rainbows and smiley faces, didn't we?
Yes.
So the essence of factoring by grouping is this. You are trying to group some terms together that share something in common so that you will end up with one binomial that is being multiplied by two different things. And you want that, and that binomial has to be the same. And then what you're going to do is you're going to recycle that binomial right here. And then you're going to multiply that recycled binomial by what is occurring outside both of the houses, so to speak. OK? So that's basically what you're doing. So let's take a look at B. X plus 3x times y plus 4 minus 2 times 4 plus y. So in the first case, we had the exact same binomials. Do we have the exact same binomials here?
Yep. Yes. No.
They don't look the same.
They are. Oh, addition, the order doesn't matter.
Excuse me?
In addition, the order doesn't matter.
in addition, the order doesn't matter, does it? No, it doesn't. So 4 plus y is the same thing as y plus 4, right? So I can rewrite this whole binomial. I can go 3x times y plus 4 minus 2 times y plus 4. Are the binomials the same? Have I done anything to change the nature of this problem so far? No. Ethan?
Can't you also do 3x minus 2 times y plus 4?
We're getting there. We're getting there. So now we have made the binomials that the 3x and the negative 2 are being multiplied by. So now that we have identical binomials, we can factor this appropriately. What is going to be a simpler way of writing 3x times y plus 4 minus 2 times y plus 4? What's the simpler way of writing it? Jenna?
3x minus 2, or the quantity 3x minus 2.
The quantity 3x minus 2. And where did you get those two terms, by the way?
They're outside of the parentheses that we did in holiday.
Okay.
And then times quantity y plus 4,
And where did you get the y plus 4?
which is inside the parentheses. And if you expand that, you will get, or if you do the rainbow smiley faces, you'll get the same one.
Excellent. So we have successfully factored b.
So that's the answer.
That is the answer. This is the answer right here.
Oh, you don't have to like solve it?
Well, if you multiply it out, you would get this. We want it factored. We want it factored form. So yeah, this is it.
Is that that's so easy. Is that the
Yes, it is. The fundamentals of factored by grouping are very simple. Yes.
That's all the ones that were just right here.
Yes.
Is that the answer to A?
The answer to A is the quantity a plus c times x minus 3. And that's it. One more question, then we're going to move on to a more complicated factor by grouping problem. A problem that you'd see more often than these.
So you prefer A and B, that the ones in the rectangles, is that you don't have to like keep going and like
You were
figure out,
done.
like,
You are done.
Okay.
That is it. That is the factored answer.
You don't need to do the rainbow smiley faces.
No, that would, if you needed to expand it, then you would have to do the rainbow smiley faces foil. So we're going to move on to question C. Okay, question C, you have bx plus 2x minus by plus 2y. So now we have a polynomial with 4 terms. And we're going to have to start by going through our checklist. What is the first thing we look for in all 4 terms? Henry? A greatest common monomial. Do they have a greatest common monomial? No. Is this it cannot be a difference of squares. A 4-term thing is not going to be a difference of squares. It can't be a square binomial either. Have we ever multiplied 2 binomial factors together to get a quadnomial? No. So we have to factor this by grouping. So what we're going to do is we are not going to change the nature of this problem. However, we are going to add some parentheses and group 2 binomials together, and the other 2 binomials together to see if we can factor them individually. So what I'm going to do is I notice that this term has an x and this term has an x. So I want to group these together. I notice that this has a y and this has a y, doesn't it? Yep, it does. Now this is going to be a little tricky. We're going to have some math magic going on. I also notice that both of these are negative, aren't they?
Yes.
And I notice that I have a positive in here.
Can you turn that into positive?
So here's what I'm going to do. I'm going to factor out. So I'm going. Sorry, before I get there, I'm going to group this whole piece together as well. In other words, I'm going to be grouping it here and combining these 2 binomials together. Have I done anything different? Have I created a new binomial or a new polynomial? No, because I still have bx plus 2x plus negative by plus 2y. Well, because if I don't put something in between here, it means that I'm multiplying, and I'm not multiplying. So yes, we're adding negative. Oh, sorry, minus 2y. My fault. Okay, so hold on a second. Let's go on. So bx plus 2x. What goes into both of those terms? X. So I'm going to factor out an x from this binomial. And when you factor out the x doesn't appear. It goes on the outside. So I'm going to divide both of these terms by x. bx divided by x is? 2x divided by x is? And that's positive 2. All right, plus. So looking here, I have two negative terms. What goes into both of these binomials? What goes into negative by and negative 2y? What goes into both of them? Emily? Negative y. So I'm going to factor out a negative y. So I'm going to divide this by negative y. Divide this by negative y. Negative by divided by negative by is? B. Excellent. Negative 2y divided by negative y is? Positive 2. So if I'm adding a negative, well, isn't that just the same as subtraction? Yes? Okay. So I have this answer so far. Am I done? No. But oh my goodness, it looks just like this problem now, and it looks just like this problem.
So we just put that into that.
All right, we're getting somewhere. So what is my final answer going to be? What is my final answer going to be? Trevor B?
X minus y.
The quantity x minus y.
X minus y, thank you.
No worries.
The quantity of b plus 2. That's so magical.
And that's the final answer. It's math magical.